the October monthly public AstroTour. My name is Lee Zhang. I'm a graduate astronomy student here at the University of Technology, and it's my pleasure today to be introducing Michael Williams. Michael did his graduate studies at the University of Calgary on finding exoplanets in groups of stars called globular clusters. He also, interestingly enough, turned a Cold War era satellite tracking telescope into something that he could use to observe asteroids and other things too. I can't remember. So that's his graduate work. But now, since then, he's worked for various observatories, and his latest job is working at the university looking after our telescopes, as well as making equipment and demonstrations for undergraduate courses. And so that's why you might have seen Michael around if you've come to previous tours upstairs. If anything breaks, we shout, "Mike, where are you?" And Michael will be talking about astronomy, astrology, and astrophysics today. How are they related? What's the difference between them? And how has history transformed the meaning and the relationship between these three fields throughout time? So,
right.
Mike. Sorry, Mike. One announcement, sorry about that. Astronomy on Tap, TO, standing for Toronto. We're just doing an advertisement for that. It's a new outreach program where you have beer and astronomy together. So if you want to hear about future events for astronomy on tap in Toronto, go to dunlap.utoronto.ca, and you can see there. Mike.
Okay. Okay, so astronomy, astrophysics, and astrology. What's in a name? So this talk really, I started thinking about this talk quite a bit over the last few years. One question I get a lot is what's the difference between astronomy and astrophysics? And that one is easy to explain, but I mean a lot of people in the field actually don't even really know the difference between them. But then there's astrology, which to a lot of people sort of in the scientific community, okay, so better to see the screen. And if you feel like falling asleep, none of us will know, as long as you don't sort of drool on the person next to you. So astrology is something very different to a lot of people in the scientific community, and it tends to get dismissed, and modern astrology in some ways quite rightly so. Let's see if this actually works, sort of. Okay, so the universe is awesome. I mean I really don't mean awesome like it's used every day by people, things like, man, that cake is awesome, but that cake is pretty awesome. But I mean it in the literal sense, in the sense that it can actually inspire awe in people. So there's some nice people being awed by the universe. And why shouldn't the universe inspire awe? So the universe is this amazing thing that exists on so many different levels of scale, so many different sizes. All the way down from subatomic particles, which it actually really doesn't make sense to talk about how small they are. They're just that small. But we can say that it's about 1 billion times smaller than the width of a human hair. And smaller than that, certainly. And then all the way up to superclusters of galaxies. So these are clusters of galaxies that are hundreds of millions, up to even billions of light years across. And they gravitationally interact with each other. They move through space together. And it's just massive. So the universe is awesome, and I mean that quite literally. But as awesome as the universe is, it's actually really amazing what people have figured out about the universe as well. And so I'll just give one example. I'll talk about one astronomical object. And not even all, just some of the things we've figured out. So here's the sun. It's a lovely picture using a hydrogen alpha telescope. So you get like lots of nice detail on the surface. You can see flares. So this is not a view of the sun you usually get. And we can look at the sun, and instead of just looking at it as a lovely picture like that, we can actually take the light from the sun, spread it out into a rainbow, and we can look for the fingerprints of elements in the atmosphere of the sun. So each one of these little black lines and huge black bars, this is all part of a fingerprint of different elements. So we know the sun is made up of hydrogen, we know it's made up of helium, we can see things like carbon monoxide, molecules involving iron, all these things in the atmosphere of the sun. So without ever going to the sun, we actually have a good idea of what it's made up of. We know how big the sun is. So again, if we want to measure something on Earth, we just walk up to it with a tape measure, measure it, nice and easily done. But we can't do that with the sun. Where would you get a tape measure big enough? And it'd have to be very, very flame resistant. And it's actually kind of hard to figure out exactly where the surface of the sun is. So we actually did this partly using an event called the transit of Venus. So right here, this little black dot is the planet Venus, and it's passing in front of the sun. So this is a picture that I took in 2012. So this was the last transit of Venus visible here. And it passed in front of the sun. We can actually use that to figure out how far the Earth is away from the sun. And then using some simple trigonometry, once we know how far the Earth is away from the sun, we can actually figure out how big the sun is. And it's massive. It's hundreds of times bigger than the radius of the Earth, and volume-wise, it's thousands of times bigger. And so the transit of Venus is actually a very interesting event because it's an event that happens twice in about 100 years or so. So you get two events fairly close together, and then you have a big gap. So this last one was in 2012, and if you missed that one, the next one is in 2117, December 10th to be precise, 2 minutes before midnight if you were in England. So that's one of the most amazing things about astronomy, is we can predict to, within seconds really, this event that's not going to happen for over 100 years. I'd like to see the TTC get even close to that. And that's just the level, it comes from the level of our understanding of how things work. So another thing we've done is we've weighed the sun. So again, normally on Earth, you would take some scales, put the scales in it, and weigh the object, and then figure out its mass from there. But of course, with the sun, we don't have asbestos scales that would survive the sun. It's a really long trip to the sun, and the sun's really big. So we can't weigh it that way. But we can actually look at the motions of the planets that orbit the sun. We can look at the motions of planets like Venus, we can look at the motions of planets like Mars, and we can use that to figure out how massive the sun is. And it's very, very massive. I think it's 10 to the 29 kilograms or so. So this huge mass compared to anything else we have any idea of. Even the Earth pales in comparison to the mass of the sun. And we've learned all this through very, very careful observation, through figuring out basic things and then adding that to other basic things we've figured out. And we eventually got to the point where we know what the sun is made up of, we know how big it is, we know how massive it is, and we actually know many other things about it. Okay, so So that's all really good. But what do we call the science of studying things out in space? Is it astronomy? Is it astrophysics? It certainly isn't astrology. But is it astronomy or astrophysics? And the truth is, within the community, the two words are almost used interchangeably. And there's actually an inside joke amongst the community. And the joke is, if you're getting on a nice transatlantic flight, you have 7 hours of sitting on this plane ahead of you, you're settling down, and then your neighbor sits beside you. If it turns out to be some crazy looking guy that you don't want to spend 7 hours talking to, you tell them you're an astrophysicist. And generally when you tell people you're an astrophysicist, they'll look at you, maybe a little blankly, and say, wow, that sounds really hard. And then they'll turn and talk to the person beside them. So you get a nice quiet flight. So I actually tried that once, and I got someone who spent 2 hours telling me how their high school physics teacher ruined their lives. But so it doesn't work all the time. But people do have this different idea of sort of astrophysics, the physics part, and astronomy. So if you end up sitting next to someone nice that you actually want to have a conversation with, they ask you, what do you do? You say, I'm an astronomer. And inevitably, they'll ask you something like, what happens when I fall into a black hole? Is there life out there? One of these questions that they've been saving up for most of their lives until they met someone, coincidentally on an airplane, and can tell them all about that. So then astrology. So astrology is a word that people actually tend to mix up for astronomy. And one of the top 20 universities in the world is not immune from that. So this is the magazine I get from the alumni department of the University of Toronto. And so, A, they gave me a promotion. I'm now a doctor, which is nice. And B, I'm in the Department of Astrology, which is maybe not as nice. Although I suspect I could make more money. But a lot of people actually do mix up astronomy and astrology. And usually for most people, it's just reaching for the wrong word. They both sound very similar. They both have astro at the front. And they both have astro at the front because they both deal with stars. So it comes from Greek. So astrology is basically the divination from stars, and astronomy is studying stars. And so they sound similar and people get confused. But we actually do run into people who honestly, in some ways don't know the difference, or in some ways are miffed that there actually isn't a department of astrology at the University of Toronto. So we actually deal with calls in the department. About once a month people will call asking about astrology. And there was one person who was actually quite irate that one of the top 20 universities in the world does not have a department of astrology. But yeah. Okay, so what is astrology? Well, actually, we'll take a step back, and I'll just define each of them in a very, very literal sense. So astronomy is the study of the motions and positions of things in the sky relative to the Earth. That's pretty much verbatim technical definition of astronomy. Astrology, on the other hand, is the study of the motions and positions of things in the sky, but with the idea that those positions and motions have an effect on people on the Earth. So the core part of astrology is what happens in the heavens affects what happens to people. Now certainly what happens in the heavens can actually affect things that happen on the Earth. So we have tides due to the moon and things like that. But affecting people is something very different. And finally, astrophysics. So astrophysics is a branch of astronomy where we actually take physical principles and apply it to things up in space. So this is a slice out of a model for an exploding star. It might look a lot like a brain. I certainly saw that when I first saw this picture. But this is a model. So we took physics that we know. We know things about gas. We know things about fusion. We know things about plasmas. We combine it all together into a computer, and we come up with a model. And this is a model for an exploding star that's hundreds of times more massive than the sun. So that's astrophysics. So astronomy has a lot to do with motions and positions relative to the Earth. Astrophysics is taking physics and using it to try to understand things in the sky. And historically, the division between the two is actually really, really important and interesting. So one thing astrology claims it can do is it claims it can tell you things about people's personality traits. So for one astrological sign, here's some of the traits: generous, dependable, down to earth, patient, independent, and persistent. So how many people think that sounds like them? I mean, I at least hope it sounds like me. Okay. So how many people in the room actually know what their astrological sign is? So a fair number of people. How many people, of the people who said this sounds like them, are a Taurus? So not me. So a few people. Okay. So how about these attributes? Stubborn, self-indulgent, lazy, materialistic, possessive, and frugal. So I'm originally Scottish, so my entire country is frugal. But I'm pretty sure we're not all born in the same month. But so who here thinks that sounds like them? So a few people. So it's good honesty. So this is also Taurus, which I find kind of funny because you're persistent, but maybe you'll do it tomorrow. And that's the way astrology works, is it tends to give you sort of very, very vague general things that you can combine together in a lot of different ways. So at one point in your life, I'm sure this described you, and this probably described you at a different point in your life. So the interesting thing is, market research people in the late 80s and early 90s were trying to grapple with trying to figure out what types of people are out there and what types of people are. And it's actually really, really expensive to sit down with people and figure out their personality. It takes a test of about 500 questions is what they usually have. It takes like an hour to do the test, and there's a lot of work to analyze the results. So they didn't want to do this. So they actually put in a lot of time and effort into researching whether astrology accurately predicts people's personality traits. Which is it's amazing reading through psychology journals talking about astrology. And what they found is astrology does a really bad job. Well, what they found first of all is there's really no correlation between what month you're born and personality traits. So people born in the same month can have completely different personality traits, which is not surprising. There are some interesting things that come up. So research has shown that a large fraction of hockey players in the NHL were all born in the same 3 months. So does that mean astrology is right and they just never said, oh, you will be in the NHL? Well, not really. You can actually think about it quite easily. So those 3 months are the first 3 months in the year where you're allowed to join. So if your birthday is after a certain date, you can start hockey that year. And if it's before that certain date, you have to wait a whole year. So these kids are generally the largest, the fastest, the most coordinated people in their year. And so they tend to get played more, they tend to get more practice, and so eventually they get better. So for me, I was actually born 2 days before the last day I could register in school. So I was always the youngest, I was always the smallest, which probably affects things as well. But it's not astrology, it's not the stars affecting you. So astrology in newspapers. So I went out on September 23rd and I bought the Star newspaper. So every day, most newspapers in North America devote at least 1/8 of a page to astrology. And so you can find your sign and they'll tell you what kind of day you'll have. So I am a Pisces. So let's see. Defer to others. One person could unusually be silent and withdrawn. I hope that's not the person I'm supposed to defer to, or it'll be a very, very quiet day. Your caring help will melt barriers, but perhaps not as quickly as you might like. Your sensitivity could become more instrumental than you are aware. So I'll have an effect, but I'll have no idea what that effect was, which is actually a really good way to write a prediction. Because I had no idea what my effect was, but somewhere out there's someone that I positively affected. So for the tonight thing, it says say yes to an offer. Unfortunately, that night, the only offer I had was would I like bags with my groceries? And I had actually remembered to bring my reusable bags, so I said no. So who knows what kind of wonderful life I could have had if I just forgot my bags. So that's astrology in the newspaper. So here's all the articles on astronomy on that same day. So I'll give you guys a couple minutes to read through all these articles. And I actually didn't pick this day at random. So September 23rd is the day that newspapers would have written about a fairly major story in astronomy news. So it has to relate to a project called BICEP, who earlier in the year had announced that they had detected primordial gravitational waves. So they had announced that they've detected these, and you detect them by looking for changes in polarization of the cosmic microwave background radiation. And so that day, there was an announcement by a satellite called Planck, which was measuring the dust in the galaxy. And they made an announcement on their prediction, on their measurements of how much dust there is in the galaxy and how much it would affect the measurements BICEP made. And what they found sort of called into question some of what BICEP said and just how confident the results from BICEP were. And the Star did not report on that at all. So that's an interesting story, and it's still an ongoing story. So later this year, Planck and BICEP teams will actually be releasing papers jointly, looking at, again, what confidence we have in that detection. So let's start out by looking at how things move in the sky. So if we look at how things move in the sky on a daily basis, so that big bright blob was the sun, those are the stars. I've nicely put constellation lines in. So the thing I'll teach you about astronomers is most astronomers don't know a lot about constellations. So it's great the planetarium actually has lines that we can put in. It makes them a lot easier to find. If only the sky had them as well, that would be great. So if we watch the sun move, it starts here. This is the west, this is the south, or this is the east, west, and south. So things rise in the east, set in the west, at least when we're looking south. You can see that towards the north part, there are things that actually never set for the stars. But the sun rises, and the stars rise and set as well. And this is all just due to the rotation of the Earth. So this is the rotational motion of the Earth. You can think of the Earth as a sphere with all these dots above it. And as the Earth rotates, things look like they're moving in the sky. So that's daily motion or diurnal motion. So now a little bit about constellations. I mentioned constellations. So what are constellations? So there's 88 constellations. There would never be a new constellation. This is what the Astronomical Union has decided they are. In the northern hemisphere, almost all of them come to us from Greek and Roman times. In the southern hemisphere, where the Greek and Romans had never traveled, there are new constellations that were made up during the age of exploration. So here's one constellation. It's the constellation of Orion. This is a winter constellation. So if you see this high in the sky in the evening, you're actually sort of late winterish. So Orion right now doesn't rise until about 1 in the morning. But it's this beautiful constellation. It has the 3 stars in the belt. It has this lovely red star called Betelgeuse, this nice bright blue star called Rigel. It has his sword hilt here, which has a place where new stars are being born, the Orion Nebula. And this is one of the nebulas which, if you get to a nice dark site, you can actually see with your naked eye. So this is a big region of glowing gas in space. So that's a really bad definition because almost everything in space is a big or maybe big region of glowing gas. But this is a big region of glowing gas where new stars are forming. So constellations were developed by lots of different cultures around the world. In this talk, I'm going to mainly talk about things that happened in Europe and mostly based on Greek and Roman. But all over the world, people looked up at the stars and saw patterns. And they gave names to those patterns and they tried to remember things about those patterns. So Orion is a hunter. He has a shield made of a leopard skin. He has a club, although that doesn't look like a really great club, but apparently back then that was an awesome club. And he's a hunter. He's the best hunter there is. And he once went out and he boasted that he's going to go out and kill all the animals in the world, which angered the god Gaia. And so Gaia sent a scorpion to poison Orion. So this is the constellation Scorpius. And so it poisoned Orion. Orion collapses. And so one way to remember where Scorpius is relative to Orion is Scorpius and Orion can never be in the sky together. And it's because of this act of attacking Orion. When they're put up into the sky, they were separated by about 180 degrees. So Orion and Scorpius are in opposite sides of the sky, never to be up at the same time. Now, luckily for Orion, there was a snake bearer named Ophiuchus, who came along with an antidote and saved him from dying to the scorpion venom. And so if you want to remember where Ophiuchus is in the sky, it's actually midway between Orion and Scorpius. So Ophiuchus is standing between Orion and Scorpius in the sky. And then finally, what is a hunter without things to hunt? So Taurus the bull is the next constellation over from Orion. It has a really bright star called Aldebaran. It's a really nice red star. It's one of the few red stars you can see in the sky. And if you ever want to find where Aldebaran is in the sky, you just find the belt of Orion and then follow that line across the sky till you hit a red star. That's Aldebaran. And that's part of a huge cluster of stars called the Hyades cluster. It's one of the closest open star clusters to us, and part of the constellation Taurus. So that is just an example of the way Greeks remembered where the stars were in the sky. They had these constellations, and they used those constellations and stories about those constellations to remember where the stars were relative to each other. So we talked about daily motion of the sun and the stars. So that's due to the Earth's rotation, but the Earth also orbits the sun. And so because the Earth is moving around the sun, the direction it's facing at night actually changes. And so you get different stars in the sky. And so this is a little animation that shows all the different constellations that the sun passes through as it goes throughout the year. So this is actually really, really neat and useful for us because we can see, oh yeah, there's the sun goes through that constellation. It goes through Scorpius there. But you have to imagine going back in time to civilizations that were trying to figure out where the sun was relative to the stars when they can't see the stars when the sun is up, except for during an eclipse. And so they actually managed to figure it out. They managed to figure out where the sun is in the sky relative to the stars. And so here's a plot. So this yellow line is called the ecliptic. This is the path of the sun through the sky. And so it passes through constellations. And so for astrology, what they do, or at least modern astrology, is they divide the sky up into 12 equal parts, give it the name of a constellation, and then the dates where the sun is in that constellation is the dates of your astrological sun sign, which is what we get in the newspapers. So there's a few problems with this. First, they're equal sizes, but the constellations themselves aren't. So say if we look at Aries, it's this really small constellation here, and then compare it to Pisces, which part of it's here and part of it's over here. It's a much bigger constellation. So dividing the sky up into equal parts doesn't really make sense if what's really important is this effect of these stars and the sun being in this position relative to the stars on your life. So another problem is the constellations actually overlap along this line as well. So you can see, where's a good example of that? Okay, so here's Sagittarius and Aquarius. And you can see they actually overlap a bit in the sky as well. So where do you cut off Aquarius and where do you cut off Sagittarius? So I can put a sun in here to represent it. So I put these lines in and I named them based on the dates given in the newspaper. So this is the section for Taurus. So here's the sun. So it should be in the constellation Taurus, right? So there's the sun and there's the constellation Taurus. So that's a bit of a problem. And it actually happens all along here. The dates that they give for these constellations. Okay. My outlet's on the back. Okay. So hopefully we can miss impending doom of the computer. And this certainly was not in my horoscope today. It didn't say, remember, plug in your laptop. Not once. And that would have actually been incredibly useful. So anyway, so the sun here is not in the constellation Taurus. When the newspaper tells you that your sun sign Taurus should have the sun in it. So that's a bit of a problem. And the problem comes from the way astrology actually does things. So I'm just going to get out of this for a second. Okay, I'll just do it that way. Okay, so hopefully this actually comes out with the lights off. So this is actually an effect called precession. So I have a top here and a nice webcam, so hopefully it'll show up. So can everyone see the top when my hand's not in the way? Sort of. Yep. Okay, so the top is spinning. So notice once the top actually starts to lean a little bit, the rotation axis actually rotates as well. So this axis of rotation is rotating itself. So there's one thing I want to point out with this, is eventually the top is going to lose energy because there's friction here and it's going to fall over. That will definitely not happen to the Earth. You have my guarantee that will not happen to the Earth. But the big thing is to take away this idea of the precession. And it gets really, really bad as the top tips more and more over. So there's a couple things with this. So the first is the precession actually seemed quite fast. But you have to remember that the top itself was spinning at about 100 times per second. And so the precession went round about once every 2 seconds or so. So it's actually very, very slow compared to the rotation of the top itself. So here's a really confusing diagram of what we just saw. So here's the top, it's leaning to the side, and then this whole axis is rotating around. So the same thing happens with the Earth. So the Earth rotation axis is tipped relative to the moon and the sun, which tug on the Earth, and that causes the Earth to precess around. So the place where the North Star is actually changes. So right now we have a North Star called Polaris. So the Earth's rotation axis is pointing at a star called Polaris. Eventually in the future it's going to be pointing at a star called Vega. So this precession actually happens about once every 26,000 years. the Earth's rotation axis will go completely around like that. And so the effect of that is it actually shifts the time that the sun is in each of these constellations. So I'm going to use my doctorate in astrology, and I'm going to fix this up for it. So I accounted for the fact that not all the constellations are the same size. I accounted for the fact that sometimes they overlap, so I had to pick places where one would be more dominant than the other. And I accounted for precession. So now Pisces is actually in Pisces, Taurus is over here, everything's fixed. Oh. Okay. So I can also fix the horoscope for us. So there's the fixed dates. So if you want to know what your actual sun sign is, you can look it up here now. And of course, one thing I forgot to mention is there's actually a 13th constellation the sun runs through. It's that constellation Ophiuchus, which saved Orion. And so if you're born between December 7th and December 21st, you're actually an Ophiuchian. Is there actually any Ophiuchians here? Hey, there's, okay. So I was able to accurately predict what happened that day. So the Maple Leafs did in fact beat the Flyers 4-0. And the sun didn't, or the Star did in fact not write an article about the Bicep Project. So 100% accuracy, and not vague at all. So in conclusion, astronomy is the study of the nature and positions of stars in the sky. Astrophysics is taking physics, applying it out there. And astrology is a pseudoscience based on the idea that the positions of astronomical objects can affect human personality and events. And so that's the talk. So I think we're a bit early. So there's a planetarium show. You can meet the people at the back. Telescopes are upstairs. Have a good night. So we're not actually done. So I have a little bit to say. This is exactly where most scientists leave off. They say astrology is bunk, has nothing to do with astronomy, never has, never will. But the truth is, almost every one of the famous astronomers before about 1700 all made their money as astrologers. Most of the advances in figuring out the positions of things in the sky were made not because of astronomy, they were made because of astrology. They were made so people could make better predictions. Which is funny, the fact that modern astrology doesn't take into account precession, because that was actually known to the ancient Greeks. So it's kind of a funny thing there. So Stone Age astronomy, so humans have been looking at the sky since the beginning of time, essentially. It's hard for people in Toronto to really understand that, because when you look at the sky, it's this sort of gray thing with one or two dots in the sky. But if you ever get out of the city, it's hard not to look at the sky. And especially if you don't have electric lights or you don't have things like that, you don't have anything else to do in the evening, so you might as well look at the sky. And so here's an example of very early humans. So this dates to about 32,000 BCE, so about 34,000 years ago. This is a calendar of the moon's phases. That someone diligently looked at the moon, wrote down what the moon's phases looked like, and kept doing that. And so throughout the Stone Ages, people did that. People wrote things, well, not a lot of writing, but people figured things out, passed on information, and they figured out where things are in the sky. They looked for patterns. And figuring out those patterns were an amazing boon to the societies that did it. So people who figured out the phases of the moon, especially if they lived near the coast, had a huge advantage when it came to coastal navigation. Because once you know the phases of the moon, you can actually predict the tides. You can predict what time of day the tides will happen. You can predict when the highest tides of the month will happen, when the lowest tides will happen. And that's a huge advantage when you want to sail ships around the coast. Knowing the sky is very advantageous for navigation in general as well. And so people actually came up with calendars that let them remember when things happened. And so early calendars, a lot of early calendars were actually based on the moon. They were completely based on moon phases. So 1 month was one set of phases of the moon in a lot of these early calendars. And then later agriculture came along, and suddenly it became really important to know what the sun was doing. Because if you knew when the sun sort of hit its shortest day and the days started getting longer, you'd have a good idea when to plant your crops. It wouldn't be a surprise. You could plan ahead, have your crops ready to plant on time. You wouldn't plant them too early and have them killed by frost. You wouldn't plant them too late and not have enough time for them to grow. And so people developed sun-based calendars. So the interesting thing is, modern calendars in the Western world are based pretty much purely on the sun. So our calendar fits in with what the sun's doing. So every year, the shortest day of the year happens December 21st, or 22nd, depending on where you are. But there are actually still groups using purely lunar calendars. So the Islamic calendar is based on the moon. And then the Chinese calendar is sort of a combination of the two. So Chinese New Year is the second new moon after the winter solstice. Now the thing with the Islamic calendar is it actually shifts relative to the sun. So the length of the year isn't the same as the length of the year for a solar year. So when I first started university, Ramadan, I think it's happened in February. Now it happens more towards the middle of the summer. So it shifts relative to the sun. So a lunar calendar is not good for agriculture, but it's great for other things. So we have the Greeks. So the Greeks really cared about the positions of things in the sky, but they thought the Earth was at the center of things, and the sky was perfect. Things in the sky were perfect. Heavy, sort of dirty things sank to the middle, and perfect light things went to the outside. Everything orbited the Earth. But they were very, very good at predicting the positions of the planets in the sky, even though they were completely wrong about how the solar system worked. And so Aristotle is one of the most famous smart people. In Europe, his view on science, his view on philosophy, his view on astronomy dominated for about 13 centuries. And he's also one of the most famous people who is wrong about almost everything he wrote down. But for 13 centuries, he was the bee's knees. The Greeks were so advanced, they actually measured the radius of the Earth. They didn't have a space program. They didn't know they couldn't go up and see the Earth was a sphere, but they knew it was a sphere, and they could measure the radius of it through a very ingenious experiment with some very simple trigonometry. And they actually got it right to within about 20% or so, which for an astronomer is an amazingly accurate number. It's terrible if you're a financial planner, but so we move into the early Renaissance. So you have to remember, the Greeks' view of the solar system and the universe had dominated for about 13 centuries when Copernicus comes along. And he says, yeah, so that thing where the Earth is at the center, well, what if it's the sun? And so he proposed this completely different model based on having the sun at the center. Now the interesting thing is, his model actually didn't predict the positions of the planets as well as the old model. And so it wasn't completely accepted. So along comes Kepler, who uses real astronomical data. So someone actually sat down, measured the positions of all these planets in the sky without a telescope, and then Kepler got his hands on the data. And he wanted to prove his pet theory. He had this idea that the world was made up of these perfect shapes. And these perfect shapes dictated that the orbits of the planets had to be circles. And what he found is the orbits of the planets were ellipses. And I think for science, this is one of the biggest changes in attitude, is rather than saying, oh, this doesn't fit with my view of the world, this isn't a circle, this must be wrong. He said, this doesn't fit with my view of the world must be wrong. And so he published 3 laws based on his observations on how planets move around the sun. One of them is they move in an ellipse. Another is they sweep out this equal area in equal time. And there's a relationship between how fast they go around the sun and how far away they are. So Kepler, for me, was one of the greats because he said, this doesn't fit with what I think, but what I think must have been wrong because this is what I'm actually seeing. So Galileo did not invent the telescope, but he did point it at the heavens. And what he saw was a moon, not a perfect sphere like the Greeks would have said, not a perfect sphere like the Catholic Church or Aristotle would have said. What he saw mountains, he saw craters, he saw shadows, and so he saw these imperfections. He also saw the moons of Jupiter, so he saw that bodies orbit around other bodies beside the Earth or the Sun. And he saw that the Sun is not perfect. He saw spots on the surface of the Sun. So never try this at home, never point a telescope at the Sun. You can do it with special filters, but he actually saw these spots on the Sun. So the Sun is not a perfect sphere like the Church would say. And so all this was actually the beginning of a very interesting revolution. And it took Newton, who was actually born on the day Galileo died, to come along and say, what if all these physical laws that we see here on the surface of the Earth actually apply up in space? Space isn't separate from the Earth. Space and the Earth are the same, are parts of the same thing. There's no special rules. And so he came up with these laws of motion, and then he applied them to things out in space. And so finally he could give us a reason why Kepler's laws worked. He could tell us that it was because of gravity, and you calculate all sorts of things about the positions of things like comets and planets in the sky. And so now we could actually calculate the positions of objects much, much more accurately than the old Greek models. And so there's a bunch of modern discoveries. So we went from, so in the early 20s, so this is less than 100 years ago, we went from thinking that the galaxy was the sum total of the universe, and all these weird spirals we see in the sky are just gas spirals, to actually realizing that these are galaxies as well, distant from beyond our Earth. So the universe went from being about a few thousand light years across to suddenly being millions, tens of millions, and eventually billions of light years across. And we found, so here's a picture that kind of proved it. So they actually took a picture of M31 and they saw individual stars and actually saw that the stars changed brightness. There were these things called Cepheid variables. And then the same person who did this, Edwin Hubble, went on to measure these galaxies and found that they were all moving away from us, so that space itself was expanding. We figured out that the sun's energy source comes from nuclear fusion, and we were able to take that and talk about the life cycle of the sun. So the sun isn't eternal. There was a time where the sun didn't exist, and there will be a time in the future where the sun doesn't exist. But it's nowhere near happening at this point. We could take what we learned about the sun and apply it to other stars. We figured out that stars come in lots of different sizes and shapes and energies. And we found the cosmic microwave background radiation, which is a consequence of this expanding universe. And finally, we started finding worlds around other stars. So for me, this is something that happened in my lifetime. So going from a galaxy-sized universe to a big universe, that happened in my grandparents' lifetime. This is my lifetime. So he was here born after 1995. So all of you have never known a world where we didn't know there were stars around other planets, or planets around other stars. Everyone before that, there was a time where we did not know that was true. Although Star Trek kept telling us that it was the case. So I just want to say, sort of the difference between astrology and astronomy is astronomy changed over time. Astronomy looked at the sky, it saw that what it thought was incompatible with what it observed, and it changed what it thought. That's the strength of science. Science is one of those things that's evolved over time. We went from knowing nothing about the sky, scribbling pictures of moon phases on hide, all the way to finding planets around other stars. That took a long time and a lot of effort. It's a big team sport. Lots of people participate in it. And it's something that's changing. So there's lots of questions still left. So that's one thing that certainly my generation kind of thought that science had figured everything out. And you can just ask a scientist any question, they'll give you the answer to it, no problem. But there's actually more questions left to answer than we have answered already. And beyond that, there's more questions that we don't even know to ask yet. So science is changing, and that's science's strength. Okay?
That was a very, very nice talk, Mike. Thank you very much. We have a few minutes for questions from the audience.
Yep.
Robin Armstrong from Toronto runs the university course up in Aurora.
Okay.
We should have had him here tonight, but I'll inform him of this excellent presentation. It was a nice back and forth.
Yep.
When you show the map of the sky,
Yeah.
I don't know why is that east and west were flipped.
The animation or the map itself?
Just the map.
Okay. So yeah, so they are flipped, and they're flipped because things.
The very early ones. You just show a map of the sky.
Yeah. Yeah. So the very earliest one is this one. So this one, that other one is actually just a blown up version of this one.
So just the one when you saw the north and the south.
Number 6? Ah, this one. One before that? But anyway, we can talk about it afterwards, and we'll find the right slide. And yeah.
I've read that there are some that the astronomers are not quite sure that how many planets there are in this solar system. Not involving Pluto, but that there might be planets beyond Neptune, or even there might some people think there might be one between Mercury and the Sun. And you said some light on that?
So I don't know sort of the details of those studies. So basically what we can do is we can look at the motions of the planets and the wobble of the sun, and we can put constraints on something might existing. So I think something between Mercury and the sun, it would have to be something so small that it wouldn't count as a planet. Otherwise we would sort of notice its effect on other things. Really, really distant. Again, there's a possibility, but we can sort of limit how big that is. So people talk about this planet Nibiru, which is supposed to be massive and huge, and we can actually eliminate that. But something smaller, it's possible. So there's a whole area called the Kuiper Belt, which is filled with icy bodies. And bodies actually bigger than Pluto. And we're finding more and more of those every day. And they're actually really hard to find because they're really, really faint. And so it's really hard to find them. So it's not impossible that there's something there, but we can put limits on how massive it would be. Yeah?
The north points to where Polaris is, and you said it'll move.
It'll move. So,
Vega.
yep.
What time frame?
So that is, I think it's about 10,000 years or so. So it's not going to happen in our lifetime unless medical science really improves. Yeah, back in the hat.
When you guys are looking for stars and planets, how can you tell which ones are stars?
So these are planets around other stars?
Like when you're observing.
Yeah. Oh, so planets in our own solar system, how we tell is we look for things that are moving relative to the stars. So the stars are much further away. So even if you're finding things like Kuiper Belt objects, you look for things that move relative to the stars.
And what about the really faint ones that you're finding every day?
Again, you're looking for things that are moving. So you're just trying to sort of collect enough light to see it, and then if you come back a month later, it'll be in a slightly different position. Yeah, in the gray shirt.
Of the 11 Earth-sized planets you found, what's the closest and where is it?
So that's not actually my area of research anymore, so I can't give you an answer to that in any detail. So most of them are, I think, reasonably far away because they've been found with the Kepler Space Telescope. So one of the closer planets that is sort of in the star's habitable zone, and it's a super Neptune type thing that I can think of, is about 20 light years away. Any more questions?
The question as well.
Oh, yeah.
Earlier calendars good for?
So the sun-based one is really good for agriculture. Moon-based ones tend to be really good for navigation. It's good to know sort of when full moon is if you're traveling through the desert and things like that. So it tends to be societies that don't do a lot of agriculture. They tend to move around more, maybe coastal navigation. So knowing when the tides are happening is incredibly important if you're moving around the coast a lot. Yeah?
For some of the astronomical signs, there would be less sunlight, such as in the winter months, so that might affect people's nutrition.
Yeah, so there's a possibility that maybe for the first part of your life you received less vitamin D or something like that.
Are there any other scientific explanations for any other astrological?
So the studies I've seen actually find really no correlation between when you were born and your personality traits, except for some very specific things like the hockey example.
You addressed personality traits before,
or
between that and anything else such as health.
As far as I know, I can't think of any studies that have looked at it. So.
Okay, last question.
Okay, so you study variable stars.
Yep.
Correct. I heard something about amateur astronomers being able to actually contribute to that.
Yeah. So there's
by monitoring variable stars.
Yeah, there's an organization called AAVSO. So it's an amateur organization. So they collect all sorts of different things. They actually have a project to look at sunspots, which you can contribute with a very small telescope and a proper filter. They had a project that was naked eye. So there was a variable star that was actually bright enough and changed its brightness enough that you could actually, if comparing it to stars near it, just with your naked eye, you could actually detect changes in it. And then, of course, they have a very big project where you have amateurs with sort of amateur-sized telescopes, so sort of on the 8 to 10 inch size, and amateur CCD, so digital cameras. They actually collect data for brightnesses of stars, which are then combined together to make light curves. It's actually, as a professional, it's really hard to get telescope time to observe a lot of these variable stars these days because it's not a sexy science, but it's still stuff that has to get done. And so the amateurs actually contribute a lot to that.
Thank you, Mike.
Yeah, so we'll talk after.
Questions for Mike, maybe you can find him afterwards.
Yeah.